Hello, my name is Andrew Brooks, and I am a System Administrator and Security Engineer for SingleHop. Today we're going to be talking about a new product that we are very pleased to be offering, and that product is Ksplice UpTrack. Now, on its own, Ksplice is actually a free and open source technology that allows for hot updates to the Linux kernel without a need to reboot the system. Ksplice UpTrack is a service provided by Ksplice, which allows your CentOS Linux server to receive pre-built kernel and security patches, as well as having them applied on the fly. Traditionally, applying updates and security patches to the kernel requires that the updates be downloaded and installed from the appropriate software repository. While the updates may be installed, they're not actually effective until the machine is rebooted. As uptime is paramount in this industry, rebooting a server is often avoided whenever possible. However, that practice allows the system to accrue vulnerabilities, so even if the machine is updated but it hasn't been rebooted, it's essentially running an unpatched kernel. Ksplice UpTrack eliminates the need to reboot a server to apply these essential security packages, and as a result, makes maintaining a secure operating system much easier that doesn't require you to sacrifice any uptime. Now, how exactly Ksplice works may be beyond the technical understanding of a lot of end users. Suffice to say that it works and does so very well. The technical details are well documented by Ksplice, and should you wish to look into these details, I strongly encourage you to review their white paper, which can be obtained at www.ksplice.com/paper. A lot of the security risks that are present on most servers are somewhat abstract to a lot of users. So today, to demonstrate the effectiveness of Ksplice UpTrack and how it keeps your system safe, we're going to be doing a live demo by actually hacking into a web server. This demo was performed on staging servers solely for this purpose. We'll be doing this using a few different attack methods. The first exploit isn't technically an exploit at all. We will assume that a user's FTP account was given a weak password and that password has been compromised by brute force. Using this compromised FTP account, we will then upload a PHP shell to the public HTML directory, allowing us low-level command access through our web browser. This is going to be our primary foothold into the web server. This shell, in conjunction with another attack tool, will give us everything we need to gain full control of the server. From here, we will escalate our privileges to the root level using yet another exploit, and that exploit is going to be the Linux UDP send message exploit. We will then attempt this same attack again using the same exploit, which, as you will see, will fail. This is due to the live security patches that have been applied to the kernel by Ksplice UpTrack on the fly. So, let's get started and take a look at our web server. As you can see, we have directory indexing enabled, which is a security risk, but it's there by default. Additionally, this also shows that there's no malicious files currently uploaded to the server, but we're going to change that with our compromised FTP account. Using this FTP account, we're going to be uploading three critical components for our attack. The first thing we're uploading is going to be a PHP shell, which is going to give us that command level access through our web browser. Additionally, we will also be uploading a reverse shell written in Perl. The reverse shell will give us something like a reverse SSH connection to a malicious server. The reverse shell will allow us to execute our exploit code for privilege escalation, and the PHP shell is going to allow us to get our hands on the exploit to unpack it. Once all that's done, we're going to use the actual exploit code itself to do our dirty work. Now that the code has been uploaded, we can then go back to our web browser and view the contents. Using this web browser, we can see that phpshell.php has been uploaded, so let's navigate to that page. Based on what you can see, it gives us command access similar to as if we had SSH access. Running a few commands, we can see what our user level is. The ID command outputs our ID, group, and privilege information. And the pwd command prints our working directory, and as you can see, we're in the public HTML directory, and we can also view a listing of our files that we've uploaded. Now let's unpack our exploit code to set the stage for our privilege escalation. As you can see, through our PHP shell, it's successfully been unpacked. Now that our code is unpacked, we can actually navigate to the code, but we can't exploit it in the way that we'd like. So for this, we use our Perl shell, and we also connect to our Hacker Machine to make this part of the exploit possible. Using Hacker Machine and using a tool called Netcat, we create a listening socket which is going to actually catch our reverse shell and give us that SSH access to the server, only in reverse. Using our PHP shell, we can then execute this reverse shell to get the command line access. As you can see, it says that the shell has been sent back to the IP address, and based on the output, we've successfully caught that SSH shell. The whoami command outputs your ID, and as you can see, you're on staging.singlehop.com, which is our good guy web server. There's a lot of things you can't do with this account, like read the shadow file, which stores encrypted password data, or move into other people's home directories. But what you can do with it is access code that you own. Now, since we've uploaded our exploit, we own that exploit code, and we're set to execute it. We then change into our directory where we've successfully uploaded the exploit code. From here, we execute whoami to show us who we are before the attack. We then execute our exploit. As you can see, our prompt has changed, and based on the whoami command, we are now root, and ID also verifies that we're root. From here, we have full access to everything on the system with no restrictions. This level of access literally gives us permission to do anything we want to the operating system, including changing passwords, removing data, adulterating existing data, or other nefarious things. So let's close that command and go back to our good guy web server, where we have Uptrack installed, but we haven't run any updates yet. Using uptrack-upgrade and answering yes to all updates, we will functionally update our kernel on the fly without rebooting it. As you can see, the output shows CVE, which stands for Common Vulnerabilities and Exposures. Those are labels given to exploits and known security issues on operating systems. So going back to our PHP shell in our browser, let's go ahead and run the Perl shell yet again. Going back to Hacker Machine, we see that we've successfully connected to the reverse shell, and sure enough, we are the staging user, and for all intensive purposes, we're connected to goodserver.singlehop.com. Let's go back to our exploit directory and run the exact same exploit again. Now, as you can see, our exploit tells us that it didn't work. It said it didn't get ring 0, where ring 0 is kernel level access. It had this access previously, but after applying the live security updates to our running kernel using Ksplice Uptrack, this privilege escalation fails. So, as you can see, the actual most dangerous part of this attack has been mitigated. And while it's true Ksplice can't stop every part of this attack, such as a weak FTP password, it can prevent a bad situation from getting much worse.